Welcome everyone to this IFMA breakfast. We're so happy to have you here, and thank you for coming so early with your own brand of coffee to enjoy this presentation on indoor air quality. Now I'm going to read off the bio for our speaker, Martin Naranjo. Yeah, I said it right. Martin Naranjo. He's quite impressive. We had a meeting yesterday. I had gotten so drawn into his presentation that I forgot that it was a practice, and I started asking questions. So I have a feeling if that's a good indicator, you guys are going to have a lot of fun today. So Martin has worked in the HVAC industry for about 19 years, all with A.O. Reed and Company. Martin attended San Diego City College in fall 2001, where he studied environmental control systems, or HVAC. He completed his associate's degree in environmental control systems from San Diego Community College with a focus in system operations, design, and repair. And he started with A.O. Reed back in May 2002 as an apprentice, changing filters and assisting journeyman technicians in all aspects of the industry, which is a good way to learn. Since then, he has worked his way up to the operations manager position, in which he oversees the HVAC and plumbing service, HVAC and plumbing projects and installations for the service department. Martin is committed to providing the best by training and assisting the field technicians with the resources necessary to fulfill the customer's needs, which we all appreciate, and keep up with new systems and technologies available. Now, they gave me a paper with all his certifications, but that would take its own seminar for me to read them all off. But I will tell you that he has certificates in every major system, which has to do with HVAC design and all of that. So just trust me on that. Plus, the most important thing of all, he is first aid certified, just in case your coffee goes down the wrong pipe. Anyway, Martin, we're so happy to have you here. Take it away.
Well, I'm thankful to have for you guys to have me here. As you know, with everything that's been happening over the last year and a half now, it's been a little difficult to kind of get training set up. So when this opportunity comes up, it's great to have. You know, I enjoy teaching, explaining the things that are coming around and what things you could do different to help better your buildings and the health of the health environment for your tenants and your employees. So I thank you again for having me. And you know, first thing I'm going to go through is kind of present one of the first things here. If you know, please mute your microphone to eliminate unwanted conversations. If you do not wish anyone to see you, like we see a lot of people just kind of have their cameras off, which is okay. If you have any questions, you can send them via the meeting chat. We're going to have breaks in between different topics that we're going to be covering. So at that time, you know, if you have a question you have regarding that topic, it's fine if you send it in, and at the end of that topic, we'll discuss those questions to confirm that we answer you as best as possible. You know, if there's anything else aside from that, we can always, you know, meet or discuss it after the presentation if you have any further information. And of course, as we want you to enjoy the presentation, just again, you know, have your breakfast, enjoy the coffee, and enjoy the show. Okay. So the first thing is airflow. Airflow is a measurement of the amount of air per unit of time that flows through an area or particular device. And as many people currently, there's a lot of concerns with airflow. You know, having airflow in a building is very important to maintain a healthy environment, you know, to provide the adequate airflow that you need in order to provide proper air distribution. So there are common issues I want to go over as to what happens with poor airflow and how it impacts things through the process. So we're going to cover those things. The common issues that result in poor airflow are dirty filters, restricted indoor coils. As you know, many of these coils, they're pretty aged. They tend to, you know, over time, yeah, the filter is supposed to catch a majority of the sediment or the dust that's collected in the air ducts. But some of them sometimes get through and they start to restrict air coils. Blower fans, you know, they affect the amount of airflow you're able to distribute through your system. So if they're not clean, kept up, they start to build a lot of dust along the curved blades of the blower wheels. They tend to decrease the amount of airflow you're able to supply. And in turn, it also provides that dust into the airstream as well. So it's always good to make sure that those things are kept clean as much as possible. You're not going to get them squeaky clean, but you know, the goal is to try to keep them from getting to that condition. If you have equipment that has fan belts, those are very important to keep up. You know, A loose belt doesn't provide enough airflow. A over-tightened belt causes damage to the system. So having a loose fan belt is very important to make sure it's adjusted and it's sized accordingly to provide the airflow that the unit is designed to provide. So it's very important that that gets looked at.
Hey, Mark, sorry to interrupt. Can you make sure to share your screen with all of us?
Oh, I'm sorry. I thought I shared it. Hold on. Let's see, where did it go? Where did it go? There it is. I got in my mode and I just took off.
Yeah, I know. That sounds like interruptive. But
All right.
Perfect. Thank you.
All right. So there, let's see. You guys see it? Okay, we're good then. All right. So we have as mentioned, the blower fan wheel dirty, the loose fan belt, fan motor running backwards. You know, many times when there's systems that have a three-phase electrical circuit supplied to that unit, sometimes motors can be running backwards and not supplying the adequate amount of airflow. So those are conditions that can happen. Undersized ducting, you know, in all these new installations, you know, in any type of TI, there's been a lot of cases where the ductwork to the equipment is undersized and it's not able to provide the airflow necessary to the specific zone. So very important that that gets looked at and make sure that it's kept up to the right dimensions in order to provide the airflow. Closed fire dampers and manual dampers, that a lot of the times that what occurs is a person is cold and they call some of the HVAC technicians or maybe a building engineer that gets in there and says, oh, okay, let me reduce the amount of airflow. Well, that tends to cause a problem because you're reducing the amount of airflow that is designed for that specific zone or that office. And it can cause a lot of issues with air circulation, which in turn is poor airflow situation. Closed fire dampers. There's a lot of many times that you have a fire drill and some of these fire dampers are automated so that they close in a situation where a fire alarm is engaged. And sometimes those fire dampers do not tend to reopen. So it's important to confirm that your systems are operating correctly, especially in a fire damper situation. Obstruction of air distribution through the return or supply diffusers. And I'm gonna show you some examples of what we see out there. You know, having those obstructions affect a lot of things. So, you know, every system is designed to distribute a certain amount of air to a certain space based on the dimensions of the floor of the area that it's supporting. And if it's anything's obstructed or changed, it does impact the amount of airflow that's circulated through that space. And then there's any improper duct installation. So we've had situations where we find that a duct is not set up correctly. There's not enough return. There's not enough supply into a space. So those type of situations need to be paid attention to very closely. And here are some of the common issues that I mentioned. You know, you have a dirty coil, or your dirty filters. Dirty filters tend to have a problem. You know, currently, you know, the rule of thumb is that you do a quarterly maintenance, but that can depend based on the use of the equipment and what type of facility you have. You know, some of the casinos, for example, they change their filters every month due to the cigarette odors and things like that. So they're on a more frequent frequency to change their filters, but office buildings may not require as much, or residential may not require as much. So it's always important to make sure that you're keeping up with your filters and maintaining them in a clean form. Fan belts, as I mentioned, you know, you don't want them too loose. As the looser the belt, the less rotation that fan wheel is going to have, and it's going to lessen your airflow. Duct installations, you know, having ducts pinched off and, you know, collapsed. Those are two examples we have here with that pipe over the sewer line, or that crushed duct that's right there that somebody stepped over. Those are things that we want to pay attention to. As I mentioned, those eliminate proper air distribution or airflow to the space. Coil conditions, cleaning the coils, making sure that as clean as possible to eliminate any moldy odors or any type of bacteria from growing. Those are very important to have. The filter should be doing the majority of the job, but there are times where it's required to get them clean. You know, the filter can only do so much of a job. And then here we have a diffuser. that is restricted, and it's possibly because someone below it has said it's too cold, I don't need that much airflow, and they stuffed it with some type of garbage bag or some type of insulator, so that way the air doesn't come out. And those tend to cause a lot of issues, not only with the equipment, but with the air circulation through the space, which in turn affects the air quality in the space as well. So it's very important that those instances do not happen. As I mentioned here, the blower wheel, we have the curved blades. Those need to be as clean as possible. They tend to get some sediment, from the dust collection, but those are definitely important to be cleaned in order to provide the proper airflow and not create any other issues with dust in the airstream. Broken ducts, that tends to be a big problem as well with the older systems that are out there. Over time, the adhesives, tape, screws, what have you, tend to fall apart and this, split up the ducting at that point. So those are things that, if you do have those situations, you definitely want to have those corrected so that you can provide adequate airflow into the space. And then as the last, is dampers. A system, when it's originally installed, it has a damper in order to be able to control how much airflow you're directing to each section. And those dampers are very important. So once they're set, it's not recommended that it gets adjusted because it impacts a lot of other parts of the system, because you may have more air or you may get less air. Now you're pushing air into another area of the office or stealing air from another area of the office. So very important that those get paid attention to when they're doing adjustments. And then we have a thermostat, and everybody always asks me, why is the thermostat so important as far as air quality? Well, air quality, the thermostat is the component which senses the temperature, but it also controls your fan. It allows you to have control of the fan operation during a time of cooling, heating, or just in a stable condition. In a lot of ways, a thermostat in a commercial building should always be in the scheduled program, meaning it's on during the occupied period. It's never off, and that allows for air circulation, not just to be stale. So it's very important that you have your thermostat set up that way. If it's not programmed that way, I would suggest you get it programmed that way. A lot of people tend to not misunderstand the difference between auto and fan on the thermostats. When you set the fan mode to auto, it'll only turn on when it's cooling or heating. And in those times in between, the fan is not circulating any air. So very important for air quality. You want to have the fans running during your occupied schedule to make sure that you have a continuous air circulation and you're moving the air through the space. Your occupancy schedule, making sure that it's meeting your requirements for the space to be occupant, full of tenants. I would also recommend that you run the units, maybe 30 to an hour prior to having it occupied, so that you flush the building and allows fresh air to kind of come in and kind of get all that stale air that's in there and allow it to get into a good, safe air quality standard there. So running the air at least 30 minutes to an hour it's recommended for that. The location of your thermostat is very important. That tends to have an impact on temperature. If it's not, in the right location, having it in the right spot, meaning next to the return air, not in the direct sunlight. That way it reads the temperature correctly and it's able to provide the necessary airflow and temperature for the space. And we're going to talk here about air distribution as part of all of that. The most common causes for poor IAQ are due to improper air distribution. Below are examples: lack of air circulation to a space, pressure changes, negative or positive. And when we talk about that, what we're going to get into in the next part of our topic is outside air, and that's how that gets impacted. So we're going to cover that portion of it in the next topic. Inadequate air changes. That's another thing that gets impacted, and we'll discuss how that plays a big factor in your IAQ in your space. Erratic temperature changes, as I mentioned, the thermostat location, people playing with the thermostat settings. You always want to have a reasonable range for everybody because everybody has a different comfort level. But erratic temperature changes where you have it too high or too low, and you're constantly changing those temperatures. does have a big impact on the condition of the space. Air balance, as I mentioned, dampers, once a building is in place and installed, it's designed to supply a certain amount of airflow to certain areas. So air balance is a big part of how air distribution works, and that you're going to provide the best indoor air quality to every zone of the building or the space. So air balance is something that's very, kind of undermined in a lot of ways, because it's only done at the time when the building is first built. And then after that, it gets kind of dismissed and not viewed as an important factor. Undersized ducting, as I mentioned earlier, undersized ducting, it does play a big factor. So you want to make sure that the airflow being supplied to a space is sized based on the duct and then providing the adequate airflow to the space. Fire dampers and outside air are other issues that we were going to discuss as far as my next topic. And then thermostat set points. And here's a kind of a diagram of what we have as far as airflow. And I wanted to use this as air distribution. As you can see, there's a return path on the purple section. That air always circulates back. And in some cases, whenever you're in the economizer or free cooling mode, that air will relieve to the outside of the space to utilize the free cooling that's in the exterior portion of the building. And then outdoor air comes in. But there are those times where you have outdoor air coming in because you need to have a minimum outside air requirement in order to bring fresh air and introduce that fresh air into the space. You don't want to have continuous recycled air through the building or the space. So that's why there's a requirement to maintain a certain percentage of outside air into the building. So you help kind of keep that positive pressure and also bring free oxygen, clean oxygen into the space. So this is kind of how a duct layout would look and how it would be used as far as bringing outdoor air into the space as well. So at this point, we're kind of at a breaking point. I don't know if there's any questions right now in regards to that part of the topic. So that would be helpful if anybody has any questions.
Hey, Martin, I've got one. Do older HVAC systems have the outdoor air supply? Or is that something?
The outdoor air in a lot of cases, because Title 24, Title 24 put a lot of requirements through the years. And unfortunately, in a lot of older systems, the requirement wasn't as big. They definitely have outside air, but it's not something to the level where you have an economizer. It may just be a small eyebrow that's sitting on the exterior, or a vent that goes from a ceiling or outdoor wall that feeds into the space. So there's different ways that it was installed in the past, but there should be at least the minimum to be able to provide that. Yes.
Thanks. That's the only one I've seen as far as questions up to right now. So
okay, so we'll move on. Okay, now we're going to get into the outside air portion of it. So outside air enters in the system through a roof, sidewall vent, inlet, or a mechanical fan that supplies air from a clean outside air location. So in many situations, you have package units. A lot of those package units have either built-in economizers. The newer systems, a lot of them Title 24 requirements that they have over a certain tonnage, that they have economizers. Anything below that, I believe it's 7 tons or 4 tons, something like that, that requires you to only have an eyebrow to provide the minimum outside air. So it really depends on the size of the equipment and what type of environment you're going to have that unit operate. But you do have equipment that has already built in outside air louvers or economizers. For a split system, meaning the 2 different components, there's one on the roof, one inside the building, you have to duct that outside air from the outside into the inlet of that unit to provide that fresh air. And it has to be calculated as to how much fresh air you need to bring based on the capacity of the unit. In a lot of cases, you have water source heat pumps, where San Diego's pretty much the manufacturing area of water source heat pumps, it seems, because every water source heat pump that you can find is here in San Diego. Water source heat pumps have to provide either by negative pressure, draw that outside air through a vent on the side of the building, or it has an assisted fan on the roof, or what have you, supplying all that outside air into the units as one central unit for makeup air or outside air. And those systems that have those additional systems, meaning the supplier fresh air supply systems, those usually have filters on them to collect as much of the dust as possible, but those are just metal filters. They're not high-end Merv 13 level type filters, because all they're meant to do is catch any large, particles that you don't want in that airstream. And then there's a filter downstream of that at the units, at each individual unit, that will filter anything that gets past those filters. So those are the types of systems that you'll see for outside air. As I mentioned here, makeup air units draw air into the system through a filter and supply it into a duct connected to the plenum, return plenum for multiple units. Smaller system use the negative pressure from the air handler fan coil to draw outside air in. So in that case, like I mentioned there, the smaller units just kind of have a duct connected to the same side where the filter would go, and the negative pressure that it generates will draw outside air based on the need of the unit. Outside air mixes with the return air at that point, and then it's dispersed evenly through the building via the duct supply system. So what that means is that you're bringing outside air and you have recycled air coming in. So you have two different ranges of air, because you're pressurizing the building, you're bringing that return air in, and the outside air coming in. So it blends together. The temperatures change based on the mixed air temperature, and that's what's supplied into the space at that point as a mixed air system. Adding fresh air to a heating or cooling system accomplishes two primary indoor air qualities. First, it controls building pressure, and secondly, it increases IAQ by diluting the polluted or still indoor air. And that's kind of what we mentioned in the past question, note there, is that it's going to mix and provide a good level of oxygen that's necessary based on the square footage or the amount of people that are allowed into that space. That's why there's a lot of, occupancy ranges that they give you. Only 10 occupants are allowed in the space, because it's already predetermined how much outside air is going to be provided for that space. So if it's excessively overstaffed, it could create problems where there's not sufficient outside air, and you can have a lot of issues with that being good air quality situation. Minimum required outside air is 15 CFM per person, or 15% of the system total supply. So that's kind of how it's determined. A lot of the times we tend to provide more outside air. That way we have a better feel for it as far as providing the better oxygen levels to the space. But there are some downfalls to that. If the outside air temperature is not within the range that we prefer, meaning if it's 100 degrees outside and we provide more outside air to that blend, it tends to cause a lot of work for the mechanical equipment to cool, and therefore creates causes the equipment to work harder. A part of that, if you provide too much outside air at times with those same temperatures, it could be a little more difficult for the system to keep up, because you're providing a higher temperature as opposed to a 70, 75 degree return air mixed temperature. You're bringing in 100% outside air, and that makes it that much more difficult to cool it down and disperse any of the humidity, try to eliminate some of the humidity that may be brought in due to that high temperature. So outside air, how is it determined how much you're bringing in? So I put the formula in here. So, there's always the people that want to know, how do you know how much outside air you have? So there's a formula here that you use to determine how much outside air percentage you have. And I kind of briefly went over it on how we would do that. We have outside air percentage, and you have to get your outside air, your return air, and your mixed air temperature at the unit with that's moving the airflow. That way you can have an idea of what the range and the balance is of outside air. Typically, like I mentioned, we try to put it up at about 20%, even though it says 15%. We try to give it a little more. But this is kind of how we would determine, okay, do we have the adequate amount of outside air? Is it providing the temperatures that we need? Is it a good blend of outside air and return? That way we make sure we're providing a good level of IAQ into the space. So this is kind of how the formula works. So if anyone has it, you'll get it on your PDF presentation. That way you can kind of always play with it if you like. Outside air. So we talked about filtration. So in a lot of cases, those units that have a negative pressure where it draws the air into the space to the units, those typically do not get filtered a lot because it would create too much of a pressure drop. It causes that much more difficulty to try to get the air into the space. So it's dependent on the filter that's on the unit, the AC unit itself. But in a lot of cases, we do have units that have filters that supply air into the buildings to distribute to all the different units, and those have those metal filters. So that those are to the right, you'll see an example what one of those filters is. And if you look at the metal filter, Merv ratings is 1 through 5. That's not very big, as I mentioned, because you don't want it to have too big of a pressure drop, as it can create a lot of issues trying to distribute or supply the airflow to the units. You have washable filters, which are Merv 1 through 4. Those are not as great because they tend to get wet and they settle, and you start getting buildup all over those washable filters. So the metal filters seem to be the best option for the outdoor type use. And I kind of skipped my other part of it, where the location of the outside air, how important that is. A lot of we find that a lot of times there's a sewer vent that's nearby one of the outside air inlets. So you want to make sure that those inlets are not in an area such as that. And if they are, maybe having them relocated, or maybe the sewer vent relocated. There's times where they're near plants and trees, and you can tend to collect a lot of pollen because they're near a tree that generates flowers and so on. So that gets into the system. So it's very important to know the surroundings of your outside air to provide the fresh air into the building. We have some situations where we've had high vehicle traffic areas. There's a lot of buildings that are right next to a cross connection of a major freeway, and all that smoke. If there's traffic, you get a lot of that smoke coming in, smog, whatever you want to call it, coming into the space. So, you want to make sure that that's being filtered as much as possible to eliminate that. We actually had a facility that was nearby the dumps section right here in off of Convoy. And we had to install charcoal filters because all those odors were going into the building. So you have to know what you need to implement in order to provide the best quality air into the space. So as mentioned, it's very important that you understand your surroundings to your building and know what it could be impacting the fresh air going into your space. And then having restaurants and restrooms, chemical exhaust. And there's a lot of buildings that have restaurants built into their floors, or may have their restroom exhaust coming up to the nearby the outside air supply systems or vents. So it's very important that those get paid attention to. In a lot of pharmaceutical facilities, they utilize chemical exhaust for the labs. So making sure that that's not feeding into a supply air vent that brings outside air into the building. So making sure that those things you're made aware of the location of all those type of exhaust. So those are the kind of the important things with the outside air, because that is what you're bringing into the space from the outside. So the question is, what is an air change? An air change is how many times the air enters and exits a room from the HVAC system in 1 hour, or how many times a room would fill up with the air from the supply register in 60 minutes. So think about a bucket of water. If I have a hose and I just fill it up to the top and I just continue to add water into it, that water is going to overflow. And that's basically what you're doing. You're providing a positive pressure into the space, and it's allowing you to kind of change the air dynamic into the space. So that way you bring in fresh air. As I mentioned, you're bringing 20% of outside air. So that outside air is going to initially start pushing out as much of that space, that recycled air as possible, to provide you and fill the system, the space with better, cleaner air and a little more breathable. So that's why air changes are so important. There's a lot of thoughts right now with the air changes, what the requirements should be, and how many, do we have enough? Do we not have enough? And I have the formula in here for anyone that wants to utilize that as a way of determining that. It's very important to know what your systems should be supplying and what areas it is actually supplying, and utilizing that area to determine how much and how many air changes you have. So as part of the air change formula, you have supply air flow, to the room. So if I have a 5-ton unit, I know I'm going to be supplying 2000 CFM, but I have to make sure that it is indeed supplying 2000 CFM to make that determination. So you would have to get a tool that would provide that kind of information. And then you do the time, which is 60 minutes in an hour. And then the volume of the space, knowing the dimensions of the space that it supplies. That way you can determine whether that's enough, you have enough air changes for that room. And as I mentioned here, the target is at least total air changes is you want to have 5. But the ideal is 6. You want to have those air changes up to that level. That way it's providing the best indoor air quality, and you don't have any issues with odors or people not feeling well because they're not bringing in enough oxygen. So you want to make sure that that is still the case. And I have a listing of what is required, per the ASHRAE regulations as to what kind of air changes you want to see in spaces. The more, the better. But ultimately, it also depends on your equipment itself. So if I mentioned that, here we want to have 6 air changes per hour, if I have a 2000 CFM unit, in order to accomplish 8, I have to provide more airflow in order to make that happen. So a lot of the systems are not able to provide those extra additional air changes. So you may have to, pretty much oversize the unit a little bit just so that you could provide the air changes necessary if you want to go a little higher than what your ideal range is. So that's how the air changes work, or you can increase the amount of, decrease the amount of space that the unit would supply. So instead of doing 2000 square feet, you might want to cut it down to 1500 square feet. And that way it provides a little more air changes. But again, those are things that would have to be redesigned to determine those air changes necessary for that space. Any questions in this topic right now?
There isn't any in the chat, so if anyone does have one, go ahead and unmute yourself, and then we'll keep going.
Okay, I'll go to the next topic. So the biggest thing that has been asked is filtration. And, there's been a lot of questions, a lot of thoughts, and there's a lot of recommendations. And I think a lot of the recommendations have been taken for it's a requirement. And this is where I want to make sure I make things a little more clear for and understand, because, it does create a lot of issues with systems if it's not determined or evaluated correctly. First thing, you want to evaluate what level of filtration is best suited for your system or building. The type of environment. You have retail, right? We have residential, commercial, medical, entertainment, whichever. You have to know what exactly your needs are for your space. You're not going to put a medical grade type filter in a residential environment, because the amount of filtration would not be effective with your unit, because your unit's not designed to handle that type of filtration. So you have to make sure you understand the differences between the levels of filtration. You have to know the type of system. Is my system is capable of handling this? The frequency of the filter replacement. The standard is quarterly, but high traffic areas require more frequent changes. 24/7 facilities, they need to be changed more frequently as well. So, it just really depends on how your business operates and the needs of your tenants to ensure that you're providing the best filtered air into the space, and you're providing the best quality. The level of filtration, you have pre-filters. Typically, that's what you would find on a packaging in a commercial building. Final filters, you tend to have on a building that has larger level equipment. Sometimes you have facilities that have like large boxcar equipment that, anything over 40, 50 tons on the rooftop supplying air into the space. Those tend to have a pre-filter and a final filter. And then you have the HEPA filters, which are more typically used for the medical industry or any type of casinos to try to maintain that airflow and not have to, affect the performance of your air quality into the space. So those are the 3 different levels that you'll find as far as filtration for the different types of environments. So what's the filter characteristics? The main function of an air filter is to clean the air that it circulates or is introduced through a heating, ventilation, and air conditioning system. And it's very important that we understand the differences and why they're utilized. They are designed to collect and hold many types of particulates and contaminants such as dust, pollen, odors, bacteria, etc. from the air. So on the right, I have a sizing chart, a range chart of the Merv rating of filters and what kind of impact they have. So as you look in here, you have range 1 through 12, which is a Merv 1 through 12 filter, and the difference in what their quality and they provide as far as protection. So an E1, I'm sorry, the Merv rating. The range 1 is the 0.30 to 0.4. If you look into this chart, you have that specific rate. It goes anything from the small particulates to a 1.0. And then you have the second level, which is anything from 1.0 to 3.0. And then you have the third level, which is 3.0 to 10, which is typically your larger particles. So the smaller the particle, the more filtration that's required. And that's kind of how those groups are determined. When I bring in this chart, I have a Merv rating on the left side of the column that goes from 1 through 16. And as you can see, there's different ranges of the ranges are listed on the top of the chart, 1, range 2, range 3. So it can be easily identified how well it filters those particulates, for that classification of filter. So as you can see, we have range 1. We have a range 1 filter, where you could see that at range 1, you have an 8, 9, and 10 Merv rating filter, and you have it on range 1. And you can see that at range 1, any of those small particulates, it doesn't apply. So when you look at range 2, you see how much, okay, it's filtering a little more. It has a little more performance on that level. But when you go to range 3, you see that it has a higher rating at the range 3 because the particles are a little larger. And that's typical what you see currently in commercial or any type of application, the Merv filters that you would see, 8 through 10, because a lot of those systems are designed to handle those type of filters. And that's how typically they've been designed to handle those type of filters. As I mentioned, systems were never considered for viruses to be protecting versus everything that's going on in the field. So that would be your typical residential commercial building type filter that you would see in any type of application for that. Then you see, So then you see that you have Merv 11, 12, and 13. As you can see, that's kind of where the ranges under the range 1. You see the filtration on range 1 start to go up as the higher the classification of that filter. But as you know, there's been a lot of discussions that Merv 13 filter should be implemented. But as you can see, it only filters 50% of that range. So you still have another 50% in that range that it's not able to get captured because it's only performing at that 50% capacity. But if you look at range 2, it's at 85%. Right, and then you have at range 3, which is 90%. So as we go higher and higher on the Merv rating, you see that the ranges to start to increase higher and higher for all three, and the performance rates for each Merv at that point. So Merv 8 removes 70% of all particulates 3.0 microns and greater. Merv 10 removes 50% of particle sizes 1.0 to 3.0 and 80% of 3. So I have a brief description of how these filters are performing based on the Merv, anything from Merv 8 up to 16. So that way it makes it really a little easier to understand. So when we're looking at this chart, if you see where viruses live, they live on the 0.01 to 0.1 range. That's generally where any viruses or any bacteria tends to live. So what tends to happen is the higher the rating, of course, you have these ranges where you're protected against bacteria, but you have to make sure that you have the right rating filter for those type of instances of bacteria and viruses. So Merv 16 would be this level right here, of course. It'll protect versus viruses, and again, it'll keep a clear portion of the bacteria. Then you have Merv You have the Merv, let's say the range 2 filters, they only protect against the bacteria levels here. And then you have the higher range, which are, I think it's 3.0 to 10 microns that reaches, that small portion of the bacteria and different types of dander, anything such as that. So these are the filtration rates in a chart of how it's dependent on the particle diameter, so that it can make it easier and less of a hassle to understand how filtration works. So that I hope this provides a lot of information for you. I think this visual kind of justifies a lot of what is said out there regarding the filtration rates. So there are frequently asked questions. We have, can a Merv 8, 10 be upgraded to Merv 13 or higher? And if so, what modifications will be necessary? So there's been a lot when COVID first started, everybody wanted Merv 13 filters. And, with our experience and knowledge of the HVAC systems, I always try to use this example. We all were wearing masks, and some people wore filters inside those masks and so on. So, I always utilize this example is if you're running with no mask, you get the free air. Yeah, you're not getting that filter air. But as soon as you put that mask, you start running and it gets a little more difficult to breathe, but you're able to breathe. Well, now you put that little, let's say a Merv 13 cartridge filter into that mask. Now that's going to reduce a lot more airflow, because it's going to require you to breathe harder to get that airflow through. So therefore, it tends to create a lot of issues, similar to what the air conditioning systems, tend to go through. You get that restricted airflow. It struggles to get that airflow through the filters. It causes the motors to work harder, and at times they can burn out because they can't get that airflow through. Systems start to ice up because there's not enough airflow getting through the system. So there's a lot of effects to doing so by increasing to a higher Merv rating. And that's why the CDC and ASHRAE, they suggest only if your system is capable of having that performance without reduction of airflow. So as you move it, we've had situations where you move up to Merv 13 and the system's not designed for it, and that's not capable of handling it correctly. You start to impact your IAQ because you're reducing airflow into the space, because that filter is restricting a lot of airflow through the system. So that tends to become an issue as well. So we don't want to run into those issues. So therefore, there are ways that you can do it. And the only way to do it is with these examples. Filter dimensions have to change from 1 to 2 inch, maybe 4 inch for added filter area to allow for longer filter life expectancy. Filter track modifications would be required in order to filter those type of filters. And the reason we would have to increase the size of the filter is so that we have a larger surface area. And in some cases, we may have to make the compartment where you're used to seeing one filter, one inch filter, we may have to add 3 extra filters and make that compartment a little larger so that there's more airflow getting through those filters. So those are things that will tend to happen. Fan motor speed adjustments, if they're applicable, we may be able to adjust the airflow or the fan speed on the motors. If they're set to medium, we can set them to high if it's applicable. That way we can kind of draw more air as much as possible without affecting the performance of the motor. So those are things that can be done. And then what additional costs can I expect? Well, the cost difference of filters, and I will tell you firsthand with a Merv 13, it has definitely been a struggle. The filters have sometimes doubled, sometimes tripled in price from what you're used to paying in Merv 8s. So they're very expensive compared to what you see in a Merv 8 filter, Merv 10. The other thing that tends to occur is you require more frequent filter replacements in order to maintain the systems clean and provide the proper airflow and quality air into the space. But one of the things that I haven't added in there that I completely forgot to add is the availability of the filters. We have been with Merv 13 type filters. In some cases, we have been sometimes anywhere between 4, sometimes 12 weeks just to get those filters in place and ordered in stock to try to get them done. So in some cases, some customers require that we change them every month or every other month. So we're having to order those months ahead of time just so that we have them available at the time that they're due to get replaced. So those are challenges that you tend to come across as far as the price and availability in the more frequent replacements. What issues can come from higher efficiency filters if not properly considered? As I mentioned, if you're not providing the right amount of surface area, they tend to get dirtier faster, which in turn, starts to diminish the amount of airflow being supplied, and it starts to cause issues with the design of the air distribution. So if the equipment design specs are not being kept up, restriction of airflow to meet mechanical cooling and heating minimums. Every fan, every piece of the AC equipment has a minimum amount of airflow that it requires in order to perform at its bare minimum. So if I reduce the amount of airflow, I'm going to get cooling, but not at the level where it can, it should be providing, and it can cause mechanical cooling to fail or heating systems to fail, and then it creates a bigger problem for you at that point. Indoor fan motor working harder, motors, if you think about a motor, I like to use the difference in how we drink our drinks. We have the normal drinking straw. Well, if you try to drink your drink with a coffee straw, that's how hard your motor's working. And, after a period of time, you tend to get lightheaded. That's what kind of the motor will do. It starts to overwork itself and it can't keep up. And because it's trying to draw all that air out through that system, it tends to overwork itself, and in turn it will overheat. Any questions so far on this topic?
Yes, I've got 3. So the first question is, how can we measure IAQ on a basic level?
Well, IAQ, you can use a carbon monoxide. You can check those CO2 levels. There are meters that are out there. We actually have a couple of them ourselves, where if there's a question, we can take them out there. We check the CO levels to make sure that they're adequate. You want to have anywhere between 500 to 700 parts per millionth in the space. So if you're above that, way above that, that means you're not providing enough oxygen into the space. And that's typically how we would determine that. But one of the things, like I mentioned, the sizing of the equipment and the distribution of air to that specific space has to be designed to that space. Because if you try to, we've had situations where they try to feed more air into another location that it wasn't designed to maintain. Well, you're decreasing the amount of airflow to the original space, because you're taking it to, they say, well, rob Peter to pay Paul. That's kind of the thing that tends to happen. So it decreases the air quality in that other space at that point. So you want to make sure that all of that is in balance. But the CO monitors are really good. There's a lot of facilities that have been implementing it in their space to make sure that air quality is at that level.
Great. And then the second question is, it sounds like you already kind of answered this, but what are acceptable levels for IAQ? Yeah,
and the IAQ, what we're talking about is you want to have a certain condition, outdoor conditions. That's the best option. If you have windows, open them up, you're going to have the best IAQ. The only issue with that is the temperature variations based on the environment outdoors. So if you have a condition indoors where you can work the mechanical cooling, like I mentioned, anything between 600 to 800, at that point, you're in the right location, you're in the right range of where you need to be. So you want to look at those ranges, and that will inform you and tell you that you have the right levels of oxygen entering the building, and that you have a very healthy IAQ building.
Okay, and then the third and final question I have at the moment is, what can we do to improve IAQ other than replacing filters, increasing fan speed, or air intake?
Well, the most important thing, one of the things that tends to happen right now is I keep hearing, oh, we need to open the economizers, open the outside air full capacity. And in a condition when it's cooled outside, that's great because you bring in all that free cooling. But in a condition as we are in summer now, those conditions are not going to be able to be met. So, you have to take other avenues. People are, implementing other options. You have UV. You have people that are putting little portable air cleaners inside the spaces, negative air units to try to keep, that air inside the space a lot cleaner. So there's options that you can provide. The thing is understanding what you're doing and why you're doing it to make sure that it's providing the end result that you want to see in your space.
And then now I have another one now. When do you think we will have standards for IAQ?
Well, the standards have always been set. Title 24, if you look at Title 24, they have standards of everything. In regards to the current situation with COVID, it's kind of really difficult to really change the standards of what we have. They make recommendations because, as we know, we could say we want Merv 16 filters on everything. But, in order to accomplish that, we would have to really update all the equipment, make modifications to these systems. And when all that is done, it requires a large financial, support from your organization. So when it tends to come to that, it's very difficult to accomplish because things such as that are very expensive because of the requirement. In some facilities, you have some gold, platinum, LEED certified buildings. Those are already kind of pretty equipped with some of those features already because they kind of got ahead of it to make it a healthy, clean or IAQ building, energy efficient. So those buildings are already out there. We have an actual building that is a silver LEED building. They have the HEPAs, they have this, they have outside air, they have CO monitors all over the building so that they can control the air quality in their space through their automation system for their HVAC systems.
Sounds good. I think we're good now and you can continue on. Thank you.
All right, so UV and bipolar ionization. So there's been a lot of questions in regards to this, and this is very interesting, and I wanted to touch on this because it's something that we're very it's very important to understand. As of recent, the big question keeps being brought up, of course. What other options aside from increasing filter performance are there? Well, can ultraviolet or bipolar ionization really help? What are the pros and cons? And one of the things that we have to understand is how viruses, gases, and the particulates work. And what we're trying to achieve as an organization overall, I think is meaning on the HVAC industry, is provide the best information possible to protect not just you, protect your tenants, and make the right decisions for this. So, there's contaminants, microbes, mold, bacteria, viruses, and fungi. You have UV light to kind of eliminate those type of contaminants. You have gases, which odors, chemicals, VOCs, PCOs is what you would typically use. But also, you can also utilize a lot of like charcoal filtration in order to help with that. That tends to help in a lot of cases. And then particulates, of course, dust, standard, pollen. You have filtration, and that's what the pre-filter, the final filters, those are what those help. You have the higher Merv rating filters, which of course help a big part of the smaller particles like bacteria and viruses. But you would have to get to that point, which is a Merv 16 or HEPA, to try to achieve that. And it can be very costly because your systems are not prepared, they're not designed to handle those type of filters. And at that point, the only easy option would be either a UV light. And in some cases, the discussion has been brought up with bipolar ionization. So, we'll go into those two differences there. So ultraviolet germicidal irradiation. So UV systems are tested and validated against bacteria, viruses, mold, and fungus. UV systems have been tested and achieve up to 99.999% reduction on microorganisms in service and airstream applications. So as you can see, UVs have been around for well over 100 years now, and it's been tested, it's been utilized. Hospitals use them pretty much in any other facilities to try to eliminate any type of viruses or bacteria from growth. There are several factors that need to be addressed in order to determine efficiency. These include, but not limited to, the application. So there's always a concern that, do I have enough UV? Do I have too much UV? So you want to always be, work with your vendor or your provider, your service contractor. That way they can determine what the right application would be for those type of situations, because there's so much that goes into it: the system design, capacity, airflow, temperatures, any such of that way it's determined how much time and how many light bulbs or UV bulbs are required to be able to disinfect that air in the airstream and provide good clean air to the space. So the UV systems are typically installed in the HVAC unit or in the ductwork and are designed to disinfect surfaces and the air as it circulates through the ventilation system. So ultimately, you want to make sure that it's put on your coil, because your coils, as I mentioned earlier, they tend to generate a lot of moldy odors, and that helps kind of keep that away from the airstream. But you also get to do the other portion of it, where you can any viruses that are flying around in the airstream, they can help get rid of them and disinfect the airstream at that point. So those are the key things where UV is utilized in the HVAC system. UV complements filtration, as you know, one helps the other. Although a filter is effective in trapping particulates, it is less effective on biological and chemical contaminants. For the most part, filters are as effective in trapping biochemical contaminant as a tennis racket may be on capturing sand. So think about what a filter is. As I mentioned, the filter, based on the Merv rating, it'll only capture those particulars that it's designed to capture. And then the UV, will take the other part of the particles, the smaller particles, and try to get those taken care of for you. So that way you can maintain a lower level filter grade and still be able to provide the airflow and be able to disinfect the air in the airstream. So that's why they complement themselves well in achieving the goal that you need in your buildings. So tight buildings designed to conserve energy. Why is this so important? Elevates levels of chemicals and biologicals. Odors are trapped. HVAC system is lungs of the building. So, the HVAC system circulates a lot of that air and all those particulates, mold, germs. So we want to make sure that whatever is being distributed and circulated through that system is always kept clean. So, it's very important that is maintained. Just like if we would breathe air, we want to make sure that it's filtered and cleaned through the process. Causes asthma and allergy related illnesses. A lot of the times that tends to happen when you have poor IAQ. If it's not filtered, you get that pollen germs, any type of bacteria that could, cause your allergies to react. Those are the things that we're trying to eliminate from a building standpoint. According to the Center for Disease Control, particulates account for only 35% of allergy causes. So, there's a range of what we're trying to maintain and control, and that's by utilizing the filters at that point. The remaining causes are bacteria and viruses, which is at 34%, and the volatile organic compounds at 31%. And this is kind of how the UV situation works, the installations. It's a low-cost solution, destroy bacteria, viruses, and mold, eliminate dirty sock syndrome. And this is why they're usually implemented at the coil to eliminate that odor. And yeah, as I mentioned, those coils start to sweat because of the condensation from the cold coil. So that tends to help with that situation. Improve and maintain equipment efficiency. You don't have to change your filtration because it's still able to perform at the airflows that you need. You reduce the having to clean the coils, and you improve your indoor air quality, and you save energy along with that. Now we have bipolar ionization. So bipolar ionization, also called Needlepoint bipolar ionization, is a technology that can be used in HVAC systems or portable air cleaners to generate positive and negative charged particles. So as I mentioned, this is kind of similar to what a UV works, but unfortunately, with the ASHRAE and CDC really kind of determining if this technology really works, they haven't really provided that confident backup to say that it will. They do say that you're capable of utilizing them, but they don't have enough data in order to confirm that is actually true. So I'm going to go over that as a part of this. This is an emerging technology, and little research is available that evaluates it outside of lab conditions. There are several factors that need to be addressed in order to determine efficiency. These include, but not limited to, the applications such as surface or air disinfection, air velocity and temperature recirculation rates, and dwell time, as well as the specific biological target. So ultimately, the goal of a BPI is to, charge the particles in the air and try to generate them into positive negatives. It sends them into the space and that also starts to generate and collide with other atoms that are in the airstream and in the space, and try to change those out and negatively and positively charge those, so that we can get a better quality of airstream in through the circulation of the space. So as I mentioned, bipolar ionization, corona discharge, needlepoint ionization, and other ion reactive oxygen cleaners. This is the note that's on the ASHRAE and CDC sites. Air cleaners using reactive ions and or reactive oxygen species have become prevalent during the COVID-19 pandemic. New devices that are not mentioned elsewhere is in this guidance likely fall into this category. So basically, it's a high voltage electrode create reactive ions in air that react with airborne contaminants, including viruses. The design of the systems can be modified to create mixtures of reactive oxygens, ozone, hydroxyl radicals, and superoxide anions. Systems are reported to range from ineffective to very effective in reducing airborne particles in acute health systems. Convincing, scientifically rigorous, peer-reviewed studies do not currently exist on these emerging technologies. Manufacturer data should be carefully considered. Systems may emit ozone, some at high levels. Manufacturers are likely to have ozone generation test data. So I have the information where you can find that if you wish to go to their sites, and that way you can determine and make a better judgment of their performance and how they apply to your buildings. And the UVB and BPI pros and cons. Ultraviolet UVGI it deactivates, destroys microorganisms such as viruses and bacteria. It's a proven technology, easy to install. I mean, the cons, the only two cons that I see is a short life expectancy. Some bulbs tend to last a year or 2 years. Some have gone up to 3 years. So you would definitely have to, have them replaced. And if you need to dispose of them, you can dispose of them through a recycling center to ensure that it's safely discarded and avoid any other issues. Different local authorities require certain things, so you got to make sure that your understanding of those local jurisdiction requirements as far as disposal. But for the additional safety controls, if you install them in the equipment itself, you have to implement safety controls to avoid them from being the mechanics or any type of individuals entering the compartments from being exposed to the UV, to make sure that they're protected. So that would be pretty much the only cons that I would see that would be of concern. As for bipolar ionization, they're easy to install, long life expectancy. The cons, as of now, as I mentioned, I'm not very comfortable with not knowing that the CDC and the ASHRAE organizations don't support it as much. They do advise that you should read on it, but as of now, they don't really can determine whether they're effective or not. So, right now, based on their sites and their requirements, they're not listed as a proven technology by them. So that would be the only thing that I would be of concern for me. Possible ozone generation, as they mentioned in their document, there is a possibility for high ozone generation. So be aware of those conditions. And one of the things that I will say, though, is in their documents, they do state that CDC actually recommends that you use any bipolar ionization that is UL 2998 standard certified. And that's because a part of it is due to the ozone generation. So if anything and you want to decide on going with bipolar ionization, that would be a standard that I would look for to ensure that you're getting the better product out of it that doesn't generate any bad ozone for those type of applications. Any questions in regards to this topic?
Yes, Martin. On the UV light bulbs, is there a standard for if you're going to be replacing the bulbs where you know that it's a quality bulb and it's going to do what it's supposed to do?
Well, UV, yeah. So the UVG, there's a certain range and I could provide that information as far as where the boundaries are, because UV can be pretty bad if you go to certain ranges. But being that what we use it for the HPC systems, they're already predetermined as to what application and the performance of it is. So we can provide that as far as the record, information for them to have as record on what the performance should be. And that kind of really depends, like I mentioned, you have to size the system accordingly to the UV. And in a lot of cases, you have right now, like say for a residential unit, they have a lot of drop-in systems for UV with the, that can be implemented. And those already be pre-designed for those type of capacities and for those type of systems. When you get into a design issue where UV needs to be looked at a little further and engineered, pretty much determine what the requirement will be for UV to get the right protection, that's when you get into the larger equipment that, anything I would say 10 to 12 tons and above, that is when you're going to be concerned, because you want to make sure you're providing adequate UV to disinfect the airstream, because it does move at a certain rate of air, feet per minute as far as the airflow, and you have a lot more surface to cover. So you want to make sure that you have the right specifications as far as how many bulbs you need to install, because the equipment's larger and more airflow is traveling through the unit. So that is when you want to get that looked at. And I would suggest that you contact your contractor and or your vendors that will supply you those type of UV systems.
Perfect, thanks.
Anything else? No other questions?
It looked there. This is more of a comment. Jennifer put in the chat is that they installed the BPI and they've noticed it says planets, but I think she means plants. It's probably a typo. Notice their plants are thriving, so it seems to be providing a better indoor environment for them.
Yeah, and that's where we're talking about. That some of these tend to generate that ozone, so that ozone does impact a lot of things, in those situations. But I personally, and I think on behalf of our company, it's very difficult for us to support something if ASHRAE, because ASHRAE is the organization that supports our industry, and the CDC, we don't feel comfortable supporting that or representing it in that way, because there hasn't been any clear data on it until they determine it as safe and they recommend that those options should be utilized. We don't feel comfortable in providing that. That's the only reason why we don't do it, because
so her comment with that the plants are thriving now, that could be that there's additional ozone in her building, which actually is not a good thing for the humans. Is that right?
That is correct. It really all depends on the type of ozone, because there's certain levels of it. So you want to make sure that you're not running into those situations. So again, I don't know how to measure ozone into a space, but those are the reasons why we're not supporting it in that way, because of that reason. We want to be cautious. If it's deemed a science that can be cleared and approved of, then we support it pretty much. That's how we do with the UV. The UV's been around for so long. So, and ASHRAE, CDC support it pretty substantially. So we support that in that because of that reason.
Okay, that's good to know. Thank you.
Okay. And with that said, I think I completed my presentation here. I have my information in there for you. If you ever need any information or any assistance, we have our information there. For any further questions, concerns, or any other questions you may have in regards to the presentation, you can always call or email at the hvac.ops@aore.com. And we'll be able to provide any information that you need, any assistance with answering questions. And even if you just use this for guidance, that's fine. We want to be helpful as much as possible, especially during these times. I know there's a lot of people throwing things at you, things that will 100% protect you and things so on. But we want to make sure we provide you with the best information possible. And if we don't know it, I'm sure we can find the answers for you and guide you in the right direction for that. Okay.
And everybody, IFMA San Diego will be providing all these slides to you by email after this presentation. So you have them for reference, along with his contact information if you have any further questions or guidance. you'll be getting that email.
Hey, Will, it's Linda. I just really found this so informative. So thank you very much, Martin, and you, Will, for putting this together. I really want to make sure that we get the recording on YouTube and through the website, because I actually want my office coordinators to look at it, just for their edification as well. Then, you know, all those little things about T-stats and whatnot. You know, and Warren made it so understandable for people who are not technical like me. So I really appreciate that, and let's really try to get this one onto our website and YouTube channel like as quickly as possible.
Yep. Yeah. We'll
Thank
get
you so much.
You're welcome.
Okay, guys, well, thank you all for joining us. I have one important announcement. First of all, everyone take a deep breath because we have gotten through this. This is a great presentation. Thank you, Martin. The important announcement is this: we will not be having an educational luncheon in August. Instead, we are going to have a social event where we are going to be live and in person. So watch your emails for that announcement, date and time. And thank you all for joining us. Have a great day. Bye-bye.
Bye.
Bye, everybody.